We are going to look at interpreting graphs of radical functions. In our first graph, we're going to look at f of x equals the square root of x plus 3. We're going to look at things like max and min and where the graph is increasing and where the graph is decreasing. And we'll go ahead and just throw in domain and range because I know that we can't ever hear enough explanation about domain and range because I know it's usually something difficult for students to grasp. So let's take a look at this graph. If we take a look at the left-hand side and the right-hand side, we could go into Desmos and pull this up, but it actually starts here with a closed circle. And then if we took Desmos and we panned it over, the graph would continue to go forever and ever to the right. So I'm going to just show you really quick. We'll throw this graph into Desmos so you can see it live. Square root of x, and then I think it had plus 3. So if we look at this graph live, what I was saying is it stops right here. There's no other part of the red graph. You can zoom in and look. It's actually stopped right here where y is 3. But if you click and drag Desmos, this graph goes forever and ever and ever. You could also zoom out and notice that it's not going anywhere. It's just continuing to go up and to the right. So sometimes we don't know the end behavior of the graph, and that's a great thing about Desmos. You can also use your TI-84 to expand your window and to look at, what we would consider, the infinite parts of the graph if there is one. So the graph starts with a point on the y-axis here at 3, this particular equation. And then as it goes to the right, it's going to go on forever and ever. So when it asks about a max is where a graph reaches its highest point and then it comes back down. So in this particular graph, we don't have a max. And we don't have a max because the graph, it doesn't go up and come back down. So it doesn't have a highest point. So we would have to say there is none. So we would say none for that one. But this graph does have a min. All right, it does have a min. It's located right here. This is the lowest point of the graph, and it's located, min and max are the y values. So the lowest y value on this graph is at 3. Okay, if we talk about where this graph is increasing, it's actually increasing. We're talking about the y values here. The y values are increasing from x to infinity. So this is like a location. Max and min are y values. I know this is confusing. But when they say how tall is the graph, think about your height. That's a up and down movement. That's a y value. How low is the graph? That's a y value. When we're talking about where something is increasing and decreasing, that's actually an x question. Where is the graph increasing? So where is it rising from left to right? It's rising from left to right from 0 all the way to infinity because we said it's going to continue to rise. So it's increasing in the interval from 0 to infinity. So increasing is rising. Okay, that's an example of increasing. Decreasing is where the graph is falling from left to right. So this graph has no intervals. There's no pieces of this graph that are decreasing. So we would have to say none for this one. We would have to say there is no pieces of this graph that are going downhill. None at all. And again, that would be an x value. Where is it? Where is it located? Anytime they're saying where is it located, you're naming some type of x value. If we're talking about how high and how low, that's a y value. All right, let's take a look at our domain. Our domain is x's, and we know our range is y's. So let's look at our domain. Our domain starts at 0, and it travels all the way this way. So our domain is going to go from 0 to infinity. We do have a closed point right here, so we would actually include 0, so we put a bracket there. When we do intervals, we don't usually use brackets at all because we're saying something is increasing from one number to another number, and you can't really increase at one point. So we don't usually use brackets when we're doing intervals of increasing and decreasing. Our range is how low the graph goes. So it starts at 3. So this is our y values. And then it rises slowly, but it is going to head towards infinity on the y. So again, we do have a bracket at 3 because we have a closed circle at 3, and then our y's continue to increase to infinity. All right, so we're interpreting, we're looking at it, we're seeing what it says to us, we're looking at the left and the right and what happens in the middle, the max, the min, the increasing, the decreasing, and we threw in domain and range just for the heck of it. All right, the next radical that we're looking at is not a square root. So I think it is important that you don't realize that all radicals have the same type of graph. So we're going to look at a cube root where that last problem was a square root. So on this particular graph, the first thing that I would like for you to notice is that it actually, when we look at the left end, it fills up that window. So if we zoomed out, it would go on forever here. And also on the right end of the graph, it goes on forever there also. So this graph is continuous on both ends, unlike the square root graph. If we go back and look at that, the square root graph is only continuous on the right-hand side. It actually has an endpoint on the left-hand side. So on your cube root of x, the graph is continuous on both sides. So I think that's important to look at. If we think about the max, again, a max is where the graph reaches a maximum point and then it comes back down. This graph is going forever and ever and ever and ever and ever up. So it's rising and rising and rising and rising and rising and rising and rising. So it's not going to reach a max. So that would be none. And the graph is falling and falling and falling and falling and falling and falling and falling. So here's an example of a graph having a min, where it has a lowest point. And then again, here's an example of a graph having a max. So this graph doesn't have a max or a min. So it's going to be none on both of those. But this graph is increasing. Okay, if we look from the left to the right, it is continuing to rise throughout that whole entire interval. So we're actually increasing from negative infinity from negative infinity all the way to positive infinity. So the graph is rising. And when we're looking at increasing and decreasing, we have to look from left to right. We don't ever look from right to left. So again, if a graph is going uphill, that is increasing. If a graph is going downhill from left to right, that is decreasing. So on decreasing, none of this graph is decreasing. Every single bit of it from negative infinity to positive infinity is increasing. All right, the domain are your x values. On this particular graph, our x's, since we have an arrow on the left and an arrow on the right, and we don't have any pieces to this graph, it's totally continuous. Our domain, our x's, are going to go from negative infinity to positive infinity. And our y's are actually going to do the same thing. This graph is going down forever. So our y values are going down to negative infinity. It's going up forever. And so our y values are going to positive infinity, and there are no breaks anywhere in between. So our domain is meant for that to be in purple. Darn it. So our range is going from negative infinity to positive infinity. So interpreting radical functions. Remember, all radicals don't look the same. This is an example of a cube root of x. This is an example of a square root of x. Always look at the left end and the right end. Always look for max, mins, increasing, decreasing, and throwing in x for domains, y for ranges. This is a lesson on interpreting graphs of radical functions.